What's up, everyone? So today I'm going to give you a very quick introduction to Kotlin, and there are around 100 pages of slide, but I will try to make it as short as possible. Okay, so let's start with the basic syntax of Kotlin. So in Kotlin, remember everything is an object, including basic data types. And there are five basic data types, and they are numbers, characters, booleans, arrays, and strings. So let's take a look at them one by one. The first one, numbers. For integer numbers, there are four types with different sizes and ranges, okay? And they are byte, short, int, and long. And this table on the slide show the sizes and the minimum value and the maximum value for each type. And you don't have to memorize their sizes and min and maximum values. The important thing to memorize is that um, if a data type occupies a large amount of the memory space, of course, obviously it's going to be able to represent a larger range of values, okay, such as a long. And so all the variables in Kotlin must be initialized, okay? And in case you initialize a number variable, a variable representing numbers, and if the value does not exceed the maximum value of integers, the compiler is gonna be automatically, infer its type as integers. But in case the initial value of the variable exceeds the maximum value of an integer, the compiler is going to infer its type as long, okay? And of course, you can manually specify the type of a variable as long by adding a capital L at the end of the number, okay? And also notice how we define variables in Kotlin, okay? So on the slide, all the variables are defined using the val keyword, but val in Kotlin actually means constant, okay? So that means these four variables on the slide, 1, 3 billion, 1 long, and 1 byte, they are actually constants. And in case you want to define variables whose values can be changed or modified, then you can use the var keyword instead. And var is spelled as VAR, okay? And for floating point numbers, Kotlin provides float and double. And when you initialize a variable with a fractional number, the compiler is gonna be infer its type as double by default. And if you want to explicitly specify the type of a fractional variable as floats, you can add the suffix f, either lowercase f or capital F. And this is the most important thing you need to know, okay? That is, unlike other programming languages such as C++, there are no implicit widening conversions for numbers, okay? So for example, we have a function called print double of here, okay? So we have a function of here whose name is print double. And you can see that this function takes a double as parameter, okay? And of course, if you pass a double to the function, then it's gonna be fine, okay? In contrast, if you pass an integer, okay, to the function, or if you pass the float number or float object to the function, the compiler is going to complain, okay? So this is what we meant, or what I meant by there's no implicit widening conversion for numbers, okay? Even though it's considered safe in some other programming languages such as C++, it is not um, um, implicitly done in Kotlin, okay? Um, okay, so now why there's no widen conversion. Okay, so this slide explains why there's no widen conversion in Kotlin. So basically, on all the Java platforms, numbers are physically stored as uh, primitive types. Okay, and in case we need a nullable number reference, such as integer question mark meaning this is a integer object, okay, and it can be null, okay, and so nullable number references they are boxed, okay, so that means, okay, um, um, if we have a nullable integer object A, for example, as shown on the slide, and suppose we have another a nullable long object over here, okay, whose name is B, and suppose um, implicit conversion is allowed in column, okay, suppose we assign A to B, and next, if we compare A and B using the double equation operator, okay, so in colon, by the way, in colon, double equations operator is used to compare the values of two objects, okay, and the triple equation operator is used to compare the references of two objects, okay, so they are totally different. They are totally different. Um, and we'll come back to this later, okay? So now, if you compare A and B using the double equation operator to compare whether their values are equal, the Java virtual machine is going to tell you no, okay? The result is going to be false, which is counterintuitive, right? Because they essentially have the same value, which is 1, okay? Over here, right? The reason the Java virtual machine is going to tell you no, okay, the reason is that when comparing two number objects, the Java virtual machine always compare whether they are of the same type first. And obviously, A and B, they are of different types. A is an integer object, but B is a long object, okay? And the integer class is not a subclass of long, okay? So that's why the result of comparing A and B using the double equation operator is going to result in false, okay? Which is counterintuitive. And this is gonna, so that's why if implicit widen conversion is allowed in colon, it's gonna and you have code like this, okay, it's gonna cause, unexpected bugs in your code. Okay, now, so let's go back to this slide for a while. So as I mentioned, there are two different comparison operators, okay? The first one is double equation operator, and the second one is three equation comparison operator. And double equation is used to compare the values of two number objects. Okay, so for example, we have a integer object A over here whose value is 10,000. Okay, and here we have a nullable integer object box A, and its value is also initialized to 10,000. And we have yet another nullable integer object, another box A, and it's also initialized to 10,000. And when we compare box A with another box A using a double equation operator, and it's going to be true, okay, because they have the same value and they are of the same data type. They are all boxed integers. And now let's take a look at the example on the left-hand side over here, okay? So here what we have is we have a integer object A, okay, whose value is 10,000 again. And the difference that in this example, we have a, sorry, this is also the same. We have a boxed integer A, whose value is initialized to 10,000, and we have another boxed integer, which is another box A, is also initialized to 10,000. But this time, if you compare box A with another box A using the triple equation operator, the result is going to be false. Okay, and because triple equation compares their references. Okay, in other words, they compares the pointers. Okay, whether these two names reference the same objects, and obviously they reference two different objects. Okay, so that's why the result is going to be false. Okay, got it? So again, double equation compares the values of two objects, and triple equation compares uh, the references, okay, of two objects. Okay, so keep that in mind. Okay, so now let's move on. So where we were. Okay, so since there's no implicit widening conversion in Kotlin, and in case you really wanted to do, type conversion, you can always manually do it using the functions provided by Kotlin. Okay, so here is an example. So here we have a byte. Okay, so here we have a byte here whose value is 1, and you can convert this byte to an integer by invoking the toInt function on the byte object. Okay, and in addition to int, Kotlin actually offers a lot of functions which enables you to convert a number to a different data type, such as 2 byte, too short, to int, too long, to float, to double, to char, and they are pretty easy to use. So I'm not going to dive into the details further over here. One thing to keep in mind is there is no conversion for Boolean types, okay? Because Boolean can only take two values, either true or false, okay? And you cannot convert Boolean values to numbers. And of course, you cannot compare Boolean values with numbers as well. So now you may think that a type conversion is a hassle because we have to do it manually. But in most cases, a type conversion or the type of a variable can be inferred from the context in code. Okay, and arithmetical operations are overloaded for appropriate conversions as well. So here's a very simple example. So say we have a variable L over here, okay? And in this expression, you can see we are adding a long number with a integer number, okay? So here, this is a long number, and this is an integer number. There's no type conversions needed, okay? And the data type for this variable can be inferred easily by the compiler, okay? Because this is a long and this is an integer, and obviously the data type for this variable should be long as well. So again, in most cases, we don't really have to do type conversion manually because the type of variable most of the time can be inferred from the context automatically by the compiler. Okay. And how about the numerical operators? So Kotlin basically supports the same standard set of arithmetical operations or arithmetical operators over numbers, such as plus, minus, and the star sign over here means multiplication, and slash means division, and comparison operators, greater than, smaller than, greater than or equal to, smaller than or equal to, they all work the same way as other programming languages, such as C++ and Java, okay? However, in Kotlin, there's no special characters or special symbols for bit-wise operations, okay? We rarely do bitwise operations in Kotlin, but in case you really wanted to do bitwise operations, you can use these functions over number objects easily, okay? So characters. So in Kotlin, characters are represented by CHAR, okay, with a capital C over here. And it is important to know that characters cannot be treated directly as numbers. Okay, so this means you cannot compare a character with a number, such as shown over here. This is an error. Okay, if you do so, the compiler is going to complain to you a lot. Okay, this is very different from C++, C++ and Java. Okay, so we actually do this in C++ a lot, right? And Booleans, similar to other programming languages, the Boolean represents, Boolean values, and the Boolean variable can take two values, so either true or false. And again, similar to numbers, booleans are boxed if a nullable reference is needed. And in Kotlin, we use the same set of logical operators or symbols. Okay, so this means or, this means and, this means negation in Kotlin. Okay, so logical operators work the same way in Kotlin as other programming languages. Arrays in columns are pretty interesting. Okay, so in Kotlin, arrays are represented by the array class, and you'll see later that array is actually not a class; it's a class template. Okay, if you don't know what a template is, it's better to go back and take out your C++ or Java textbook and review the concept. Okay. And in Kotlin, a number of library functions are provided to help you to create array objects, okay? And one of the most commonly used library function is array of. So this function is very easy to use, okay? So suppose if you wanted to create an array containing three integer numbers, such as 1, 2, 3, you can simply say array of 1, 2, and 3, and it's going to create an array for you, okay, containing the three numbers 1, 2, 3. And you can also, in Kotlin, you can also put objects of different data types into the same array, okay? So for example, here we have, it uses the array of function to create an array object again. But this time you can see that the three objects, okay, that we put inside the array are of different data types. The first one is an integer, and the second one is actually a string, and the third one is actually a character. Okay, so you might be wondering, why is that? Why can we put objects of different data types into the same array? And this is because all the objects in Kotlin are a subtype or a subclass of the any class. Okay, so the any class in Kotlin is the superclass of all the classes in Kotlin. Okay, so the any class in Kotlin is kind of like the object class in Java. Okay, so if you have some experience programming in Java, you should know that the object class in Java is the superclass of all, of all the other classes, right? And any here in Kotlin, it works the same way. So all the classes in Kotlin are a subclass of the any class. Okay. So instead of using library functions to create array objects, another way to create an array object is to use the array constructor. Okay, and the array constructor is a more powerful way to create array objects. So the array constructor takes two parameters. Okay, the first one is the size of the array, and the second one is an expression, such as shown over here. Okay, you can also put this thing inside the parentheses. Okay, so this is the second parameter needed by the array constructor, and you can see this is actually so this line of code, this expression looks kind of odd, right? And actually, this is called the lambda expression. Okay. So we'll talk about lambda expression later. So now, just please bear with me. So basically, what this constructed this code, what this code does is that it's going to create an array of size 5. Okay. And the constructor is gonna use this expression over here, the second parameter, to initialize each element in the array. Okay, so this means this array over here, its size is going to be 5, and the value of each element is going to be the string of the square of the index. Okay. Now, another thing to note over here is that arrays in column are invariant. And invariant means that an array of a specific type cannot be assigned to an array of its parent type. Okay, so I think this statement over here is kind of confusing. Okay, but let's take a look at the example over here. Okay, so this examples. In this example, we have an array. Okay, we have two arrays. The first one is it's an integer array, and the second array B is an any array. Okay, so which means the elements in the second array, they can be of different classes. So if you try to assign A to B, the compiler is going to complain, and this is because arrays in columns are invariant. Okay, and the real reason is that no, array is actually not a class. It's actually a template. So the real data type for A is this one, arrayint. Okay, and the data type for this array is array, angle brackets, any. Okay, array of any. Okay, sorry, let me rewrite them again. So let's use this one. So the type for the A array is this, arrayint. And the data type for the B array is array any. Okay, if you know what template means, then you should know that these two things, they are of different data types. They are of different classes. Okay, so that's why you cannot assign A directly to B. Okay, because A and B are essentially an array of different data types or different classes. Okay. Okay. If you don't like array class template, Kotlin also has specialized classes to represent array of the primitive types without boxing overhead, such as byte array, short array, int array, and so on and so forth. And of course, you can use their constructors to create byte array, short array, and integer array, so on and so forth. But one thing to know that byte array, short array, and int array, they are not subclasses of the array class. Okay, and again, the reason is that the array class is actually a template. It's not a class. Now let's move on to strings. The strings objects in Kotlin are represented by the type string, okay, obviously. And the elements of string are characters that can be accessed by the indexing operator, that is the brackets operator. Okay, just like C++ and Java. And similar to Java, strings in columns are immutable. Okay, meaning once a string is created, we cannot modify its content. Okay, say suppose you have string over here, which is initialized to ABC, for example, and because strings in Kotlin are immutable, so we cannot say something like this. Okay. Okay. This is not allowed because strings are immutable. Immutable means non-modifiable. Okay, non-modifiable once they are created. That's what immutable means. Okay, and one interesting thing to know about strings in Kotlin is that a string can be iterated over with a for loop like this. Okay, so using this for loop, we can iterate through each character in the string str. Okay, so this for loop format is kind of like the for each loop in C sharp. Now, similar to C++ and Java, we can always concatenate strings objects using the plus sign operator. Um, so this also works for concatenating strings with the values of other types, okay, as long as the first element in the expression is a string. So for example, we can say, we can concatenate ABC with the integer 1, okay, but you cannot say 1 plus ABC, okay, this is wrong, okay. And of course, we can concatenate two string objects using the plus sign operator as well, as shown on the slide. So now, Kotlin has two types of string literals, and they are escaped strings and raw strings. So in escaped strings, escaped characters are interpreted. Okay, so for example, \n is going to be interpreted as new line, okay, in escaped strings. Okay, in contrast, raw strings do not interpret escaped characters. Okay, so if you put \n, and if you output the string on screen, you are going to see this \n on the screen as well. Okay, so that's the difference between escaped strings and raw strings. Now, one interesting thing in Kotlin is that string literals can contain template expressions, and template expressions are simply pieces of code that are evaluated, and the results are concatenated back into a string. Okay, and the template expressions in Kotlin start with a $sign and consist of either a simple name, okay, such as shown over here, or an arbitrary expression in curly braces. Okay, so so what this means when the compiler says $sign is going to evaluate this value, okay, and concatenate the value with the string, okay, and because the value for this name or variable is 10, so you are going to see I equals 10 on the string, on the screen. And similarly, when compiler sees this, okay, so when compiler sees this, okay, it's going to evaluate the expression inside the curly braces. And the expression inside the curly braces is s.length, okay, which basically means the length of this string. Okay, so that's why you're going to see abc.length is 3, okay, on the screen. So uh, that's examples of a template expression. Okay, very simple, right? So now packages and imports work the same way as Java, so I'm going to skip it and leave it for you to read. Okay. So now let's move on to control flows. Okay, there are roughly four different types of control flows. The first one is expression, and the second one is when. The third one is for loop, and the fourth one is while loop and do while. So expression, the expression has the same syntax as C++ and Java. The difference that in Kotlin, an expression can return a value, okay, and this is very different from Java and C++. So for example, if expression simply means if A is greater than B, then the value for this expression is going to be A. Otherwise, the value is going to be, sorry, let me say that again. So this if expression simply means if A is greater than B, then the value for this if expression is going to be A, okay? Otherwise, it's going to be B, okay? And this code, comparing to how we normally do this, okay? So the left hand side is the piece of code of of equivalent meaning. Okay, and this is how we normally do it, right? So we compare the value of A and B. If A is greater than B, we set maximum variable to A. Okay. Otherwise, we set the max variable to B. This is how we normally do it. Okay, and comparing the expression in Kotlin to what we normally do it, you can see that the code in Kotlin is much more concise, right? However, I would say this if expression is kind of difficult to read. So I would still say don't use if expression like this in Kotlin, okay? Because it's going to make your code more difficult to read, So now the when expression, this is something new in Kotlin, okay? But essentially the when expression replaces, it's kind of similar to the switch case operator in C++ and Java, okay? And in the simplest form, the when expression looks like this, okay? So basically, you can see that the when matches its argument, okay, in this case x, against all the branches sequentially one by one until some branch condition is satisfied. Okay, so you can see when it's kind of similar to switch case in C++, and Java, except in each branch case, we use arrows instead of columns over here. Okay, we use arrow instead of column to separate a branch condition from the code. Okay, and the second difference is that we don't need to put the break keyword at the end of each branch case. Okay, that's the two major differences. And the third one is obviously the keyword. Okay, instead of saying switch, we say when. Okay, and the last difference is there's no need to put a case, keyword, okay, in front of each branch case. Um, and the when expression in Kotlin is much more powerful than the switch case operator in C++ and Java. And the reason is that, we can even use arbitrary expressions as branching conditions, okay, such as shown over here. Okay, so you can see that the branch conditions in a when expression may not be in constant. Okay, it can be any or arbitrary expressions. We can also check a value for being in or not in a range of collections, okay, such as shown here, okay. So this means if this x, okay, is inside the range of a 1 to 10, then, execute this statement, okay? So similarly, if the value of x is not in the range of 10 to 20, then we execute this, statement. And we can even check that whether a value is or not is a particular type using this is, operator. Okay, so it's very interesting, right? So now in Kotlin, for loop iterate through anything that provides an iterator. Okay, so for example, array, or a string, or a set, so on and so forth. So for looping in Kotlin is similar to for each loop in C#. And the basic syntax for a for loop is like this. Okay, we simply say for, item in a collection that provides an iterator, then the piece of a code inside the curly braces. In case you want to iterate through a range of numbers, we can use the range expression. Okay, so this means for I equals to 1 to 10, we execute this for loop, okay, 10 times, okay? And we can also control step size using the step keyword over here inside the for loop. And in case you want to count in the backward direction, then we can use the down to keyword, okay? So in this example, this means we're gonna count from 10 down to 1, and of course, we can also control the step size over here, okay, using the step keyword. The while loop, do while loop, the break statement or the break keyword and continue keyword, they all work the same way as Java. So I'll leave them for you to read. They're very simple, okay? And next one, functions. And functions in Kotlin are declared using the func keyword, okay? And the func keyword is followed by the function name, and the function name is followed by the parentheses, and inside the parentheses, of course, is the list of parameters, okay? And all the parameters must be explicitly typed, okay? And after the parentheses, we put a colon over here, which is followed by the return data type of the function, okay? And calling functions uses the traditional approach, okay? Say, for example, if you want to invoke the double function, we simply say double parentheses and we pass in the parameters. And calling functions on objects use dot notations, just like in what we do in C++ and Java, okay? And one thing to note here is that function parameters in Kotlin are defined using the Pascal notation. In other words, names of the parameters and their types are separated by colon, okay, over here, and parameters are separated using commas, okay? Again, each parameter of a function must be explicitly typed, okay? You must tell the data type of a parameter to compiler, otherwise it's going to complain. And similar to Java and C++, function parameters can have default values. And to specify the default value, we simply use the equal sign over here. Okay, so in this example, the second and the third parameters of the read functions, they are initialized to 0, and the size of the first parameter, which is an array, okay, right over here, okay. So similar to Python, function parameters can be named when calling functions, okay, to make code more readable, okay. So if you compare these two function calls, obviously the one on type is much more readable, right? And however, it is important to memorize that, if a default parameter precedes a parameter without default value, and then the default value can only be used by calling the function with named arguments. Okay, so for example, we can see we have a foo function over here, and the first parameter has a default value 0, but the second parameter has no default value. Okay, and if you want to use the default value for the first parameter over here, then the second parameter must be named, okay, when calling the function. Okay, that's what this statement means over here. Now, if a function doesn't return any useful value, its return type is a unit, okay? And unit is a type with only one value, that is unit, okay? Um, and if a function does not return anything, you can simply specify its return data type as unit, like this, okay? Colon unit, and actually this is optional. Okay, you don't really need to put the unit over here when defining the function. Now, in Kotlin, when the function returns a single expression, the curly braces can be omitted. Okay, so for example, the double functions over here. Where's double function? Okay, the double function over here, because there's only a single statement inside the function, the curly braces can be ignored. Okay, so instead of curly braces, we simply put the equal sign over here. Okay, and what's even better is that in cases the return type is can be automatically inferred, the return type can be optional as well. Okay, and in this example, the return the return data type for the double function can be easily inferred, right? Because it's obviously the return value is obviously an integer, so we don't need to specify the return type for the double function. Okay, it's optional because the return data type can be easily inferred by the compiler. Okay, now I think it's time for a little break. So in the next hour we're gonna talk about high order functions, lambdas, and some other more advanced stuff. Okay, talk to you later.